Evaluate the definite integral from 1 to 2 of 1 over x cubed times e to the 4 x negative 2 power dx. Observe that 1 over x cubed is x to the negative 3. And we see that the derivative of 4x to the negative 2 power is negative 8x to the negative 3, where negative 8x to the negative 3 power is a constant multiple of 1 over x cubed. So this is a good candidate for substitution, u substitution, where we will let u be 4x to the negative 2. The differential du is negative 8x negative 3 dx, because this is differential. Du is negative 8 over x cubed dx, and we want to keep 1 over x cubed dx, so we isolate 1 over x cubed dx. We do this by dividing by negative 8 from both sides of this equation, so 1 over x cubed dx is negative 1 over 8 du. Since this is a definite integral, we should always evaluate or obtain the new limits of integration. With x equals 1, the new lower limit of integration will be u equals 4 times 1 to the negative 2, which is 4 over 1 squared, or 4. This will be the lower limit of integration for the new integral. With the upper limit of integration x equal 2, u is now 4 times 2 to the negative 2, which is 4 over 2 squared, which is 4 over 4, or 1. 1 will be the upper limit of integration for the new integral, where u is the variable of integration. We then rewrite this given integral as the lower limit of integration is now 4, and the upper limit of integration is now 1. 1 over x cubed dx is now du over negative 8, and e to the 4x to the negative 2 is now e to the u, because u is 4x to the negative 2. We then evaluate this simple integral, but first we would need to rewrite this. We always bring the constant multiple to the front of the integral. This is negative 1 over 8, the integral from 4 to 1 e to the u du. But if we want to switch the limits of integration so that the upper becomes the lower and the lower becomes the upper, 4 to 1 to 1 to 4, we would need to negate the integral, which is a good idea in this case, because when we flip the limits of integration, we can change the negative 1 over 8 to positive 1 over 8. The integrand is e to the u du. We don't need to rewrite the integral or antiderivative in terms of u, because we obtain the new limits of integration in terms of u already. The antiderivative of e to the u is e to the u. Using the fundamental theorem of calculus, we just simply evaluate the antiderivative at 1 and 4. 1 over 8 e to the 4th power minus 1 over 8 e to the 1, which is 1 over 8 times the quantity e to the 4th minus e.